Now let's look at question C. This question asks us to translate the assembly code seen here into C. First thing I'd like to do for these questions is determine what the base case is. Here, the base case seems to be the break line underlined for part B, BTQ A0 X0 done. At done, 1 is loaded into A0 and the function returns. So when A0 is equal to 0, we set A0 to 1 before returning. Now let's see what happens when we try to inputting the value 1 into A0. Looking now at the two lines after fun, we see that we subtract 12 from the stack pointer and 1 from A0, giving us a value of 0 for A0. We then sort the RA, A0, and S0 in the stack before jumping back to fun again. We know that fun returns 1 for A0 equals 0, so we can abstract that out and jump to the next line before jow fun, which is MVS0 A0. This moves the return value that was stored in A0, in this case 1, into S0 before loading in the old value of A0, which is also in this case 0, back into A0. We then call fun again on A0 equals 0, and that will give us back 1. We next add A0 and S0 together. A0 and S0 both are equal to 1, so we just store 2 into A0. We pop S0 and RA back off the stack into their respective registers, and then we return. Let's do this again for A0 equals 2. We subtract 1 from A0, giving us A0 equals 1. We then call fun on A0, giving us A0 equals 2, and then move 2 into S0. We then load 1 from the stack into A0 before calling fun again, which gives us 2. Finally, we add S0 equals 2 to this value to give us A0 equals 4, which we return. Based on what we have seen thus far, it seems that this function recursively calls itself twice on 1 less than the input value, and then adds those two values together. We can write this out and see with a one-line ternary statement. If A0 is equal to 0, we return 1, else we return fun of A0 minus 1 plus fun of A0 minus 1. Note that although 2 times fun A0 minus 1 returns the exact same value, it doesn't have the same number of function calls. So, this line here is our answer.